All right, so remember when we draw our graph, we have to look at the domain. And it looks like at 3 is where it's breaking up my graphs. So where it says less than 3, that's what this graph is going to be. And where it says greater than 3, that's where this graph is going to be. So we create a table for each one. And so for 4 minus x, we create our table. Usually it's a good idea to start where the dotted is. So 3, 2, 1. So if I plug in 3, I'm going to get 1. If I plug in 2, if I plug in 1, I'll do one more. Let's plug in 4, I get 0. So graphing these, 4, 0, 3, 1, 2, 2, and 3, 1. And then I could do a closed circle right on that line because it says equal to here. And there's my graph. It's just a line. Now I know it gets confused. It's like, oh, what happens if just a number? Well, that's the same as f of x equals 2. That's just a horizontal number at 2. So at 2, open circle, and it's going to go forever that way. Let's look at the next one. Squared and 2x. And it looks like at 0 is where everything's being divided at. So I'll switch the color. All right, so it's at 0. That's where everything's being divided at. So then on this side is x squared, and on this side is 2x. So we create a table for each one. Let's pick these values. Right, so 0, -1, -2, -3. So if I plug in 0 to x squared, I get 0. If I plug in -1, -1 squared is +1. If I plug in -2, -2 squared is 4, and then 9. Close circle. So it's going to do one of those. And it's a parabola, right? It's x squared, so it's like a half parabola. It's chopped in half. And now on the other side, let's pick the values greater than 0, like 0, 1, 2, and 3. So if I plug in 0, I get 0. If I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in 3, 3 times 2 gives me 6. So open circle there, but it's already filled in. 1, 2, 2, 4, and then 5, 6, 2, 6. So that's a straight line there. So it's like a parabola on one side and a straight line on the other. Now, when we have piecewise functions with 3 pieces, just as a reminder, you just break it up into the 3 different sections. So we have 0, and then we have 3. So that means this graph is on this side, this graph is in between, and this graph is on that side. And same thing here. It looks like it's breaking up at -2 and at +2. So this graph will be here, this graph will be here, and this graph will be here. Let's find the implied domain. So remember, we have 2 domain restrictions. The first is x in the denominator. If so, you set the denominator where it can't equal 0. The second is x inside a square root. If so, set the inside of the square root greater than or equal to 0. So for number 5, is x in the denominator? Yes. So set the denominator where it can't equal 0. Solve. Square root. So now number line. negative root 3, positive root 3. Those are open circles because it can't equal that. Now we said it can't, doesn't mean we can't equal anything else. And so negative infinity to negative root 3 union negative root 3 to positive root 3 union positive root 3 to infinity. Now for number 7, we have both, right? Is x in the denominator? Yes. So set the denominator to where it can't equal 0. So r can't equal 8. And then is x inside of a square root? Yes. So set the inside of the square root greater than or equal to 0. Okay, since I have more than one domain restriction here, we have to find the intersection of the two. So it can't equal 8, so open circle, but it's everything else. And then r has to be greater than or equal. So where do they overlap? They overlap here. So from 0 to 8, and then they overlap here from 8 to infinity. And determine if the graph is a function. Yes, yes, yes. Now state the domain and range. For this one, the domain, if you project, it'll be from -5 to 4. The range looks like it's from -4, +4. Remember, open circle means parentheses. You know, here it goes forever, so the domain is -infinity to +infinity. And your range, it's going to be all the way down, it's going to stop at 4. So -infinity, and it stops at 4. And I'm going to let you figure that last one out.